Happy Friday. So yeah, my name is Jesse Endahl. I'm the Chief Security Officer for a company called Fleetsmith. And today I'll be talking about exactly what it says on the slide here. So before we go any further, I'm actually really curious, just for context setting, how many people know about secrets management? Cool. How many people currently do secrets management with a secrets management system in production? OK, cool. Awesome. Thank you. Moving on. So yeah, I mentioned my name and my title and stuff, but that's not much information. So a little more background on me. I was, before co-founding Fleetsmith, I was at Dropbox as an infrastructure security engineer, did a whole bunch of different projects. Love talking about endpoint security. That's kind of my thing that I nerd out on. Yeah, Fleetsmith is a SaaS product. We automate the new hire setup of new laptops for your employees, but also all the ongoing management, like security and settings, automated patching. It's pretty cool. And actually, on a related note, I was very inspired. I usually don't mention this part, but I was very inspired. At Dropbox, we didn't roll out any commercial solutions for device management. I actually used Puppet, which is, you all know Puppet, and Monkey, which is an open source kind of package manager for macOS. And those two projects were very inspirational to Fleetsmith, particularly desired state and idempotency, which traditionally haven't really been a thing in the IT world. Cool. So if you're interested in any of these topics, I've been going a little nuts this year on talks, so check those out if they seem cool. Some context on my general worldview. I think computers should handle the manual stuff. We shouldn't be SHing in, manually running a bash script, and then running a report, and then if it changes, then go back and run the script again. Obviously, that's what the DevOps movement has been all about. But again, I think that other parts of the ecosystem, like security and IT, haven't really had as much of a paradigm shift, and I think it needs it. So. There's that. I think IT and security should never get in the way of employee productivity. And this one, I actually just thought of this morning. I really love when I see companies, and this used to be really rare, companies actually adding features that differentiate their product based on security or privacy. You see GitHub doing this. You see Segment Analytics doing this now. They just launched this awesome tool to basically help you with GDPR. Apple, obviously, the whole privacy campaign around the iPhone, and Fleetsmith, we do what we can as well. So I want to see more of that, and if you work places that are actual software companies, push for this idea. I think it's really good for the whole world. Okay. And last but not least, I think products and tools should be secure by design. If anyone was here for the panel yesterday, I mentioned this. It's something I believe really strongly. And yeah, on a related note, I think this talk, secrets management, is a core part of actually building a product that's secure by design in 2019. So before we go any further, quick definition of what is a secret, because it's a little vague. The word itself, it's well, that could be really anything. For the purposes of this talk and talking about infrastructure security in general, it's really this stuff, right? It's an API token, a password, a certificate. And so that's what we're talking about here. Oops, hit the wrong button. I should not hit the right arrow, only the down arrow. Cool. So TLS Private Keys, API tokens, OAuth tokens, et cetera. Why is secrets management something that anyone should care about? Well, it's because of things like this. This is not to single out Uber. This has happened to many companies in the world. And this is what happens when you have secrets stored directly in your code, right? This actually was a gist, not a repo, but same point still applies. We've all heard of public S3 buckets. This sort of falls in the same category, where the thing you're doing by default and encouraging everyone to do and training everyone to do should be the thing that is that keeps you safe in the case of other things going wrong, right? Defense in depth. Like, what if the GitHub repo becomes public because someone messed up? Well, they got the code, but they didn't get any of your secrets. Much better story. So why Vault? In this talk, I'm really talking about doing secrets management with Vault, an open source project from HashiCorp. I'm sure everyone's familiar. This, oddly enough, I just opened up Hacker News this morning, and the latest release of Vault came out about like 12 hours ago. And someone, like, top comment was someone saying, like, why should I use this thing? And it was pretty cool. The CEO and founder, Mitchell Hashimoto, actually commented and responded, and this was what he said. And I think it's, obviously it's very accurate. It's really a tool that scales up very nicely. You can get started very small with a small team. We started using it, when we were at our seed round. We had less than 10 employees, and we're still using it, with 64 employees. So it's and like he says, it scales up all the way to like Fortune 10. I mean, that's massive scale. So it's pretty cool that you can have a tool that's that flexible. I mentioned this yesterday in the panel for those who were there, but I find a root of trust analysis to be a really powerful way to make sure that you're actually securing every layer of the stack as you move from bare metal all the way up. And I wanted to just show how many layers are actually involved in just secrets management. Right? This is one small slice of your infrastructure security. But yeah, just working from the bottom up, you've got the storage layer. That's generally going to be handled by your cloud provider. We're on Google Cloud, so we get to cheat a little bit and benefit from their encryption by default policy for that layer. But as you move up, you can see you really have to pay close attention, because if you miss one of these, you could have some pretty bad consequences higher up. Right? It doesn't matter if the building is perfectly architected and constructed if it's built on sand. So that's the idea here. Pay special attention, actually, to the top two things here, because I haven't seen it talked about anywhere. But if you want to have, like if you look at all these lower layers and you're doing encryption at all these layers, but then you write it to a persistent disk, your secret, right, your private key, right, TLS private key, to an unencrypted disk on your VM, well, that kind of just, got in the way of all the other stuff you've done here. It made it pointless. So that's why it's really important to write those to like mem disks, and you can do that in both VMs and in Kubernetes pretty easily. Okay, another thing I wanted to put in here, I kind of went back and forth on this because I think this should be something that's just really foundational, but I have actually found over the years in conversations with engineers that I've gotten the feeling that these fundamental concepts are not actually taught very clearly, even in like great computer science curriculums. So I want to just throw it in here. The best explanation of this that I've seen is by this guy, Daniel Miessler. I'm not sure if that's how you say his name, but really amazing blog post. It's super short. It's like 4 paragraphs, but it really sums it up. So I've tried to chop it down even more here just for time's sake. But real quick, identity is just you claiming literally an identity. It's like me walking up to you and saying, "Hi, I'm Jesse." You have no way of knowing whether that's true. I could say, "Hi, I'm John," and you would believe me just as much, right? That's all it is. It's like the username, but not the password. That's the identity. The second concept is authentication, proving your identity. So we do this in real life, obviously, when we go to the airport and we say, "Hey, I'm Jesse. I have this ticket to get on this airplane." They say, "Can you please prove that to me with your ID?" That's us authenticating our identities, right? And so that's usually something you know, like a password or a token, or something you have, like a YubiKey, or something biometric, like your fingerprint, your face, etc. And last but not least, authorization, which is what you're allowed to do once you have been authenticated. So it's like getting into a high security facility. You might not be able to go into every room based on your level of access, based on your job role. So that's the last building block here. And it's really important to keep all 3 of these in mind when you're doing secrets management, because you have to deal with solving all 3 of these problems, and you have to solve these problems for humans accessing the secrets and storing new secrets and reading them, as well as the machines, right? The VMs and the pods. And you have to deal with identity, authentication, and authorization for all of that stuff at every layer of that table that I showed earlier. So it's really important to keep that in mind as you move up the layers in the stack, because you have to solve those 3 problems over and over again. And how you solve them is different at each layer. There's also this really tricky chicken and the egg problem, which, to be totally honest, if you're not on one of the major cloud providers that solves this for you, or helps you solve it, I should say, I don't know how you do it. I mean, I know theoretically how you do it. What I mean by that is you're going to need a lot of, maybe not a lot, you're going to need a team of very talented engineers to actually solve this for you. So that's the question, right? Like, we have this new VM, just came out of nowhere, just spun up, or a new Kubernetes pod, and it's running a service that needs access to an API token. And the API token is in Vault. How does Vault know that it should give the API token to this random thing that's calling in for the first time, being like, hey, give me the secret, please? The answer is pretty clever. It's kind of like a Threeway handshake, I think is what it's called, similar to like OAuth, where it's like first the VM makes starts up, and both Amazon and Google have this concept of a basically signed metadata associated with a virtual machine, and that is signed by their CA, their kind of like infrastructure CA for their cloud platform, and so that gives you assurance that it gives you an authentication on that identity, right? So the identity of the VM, Kubernetes works similarly but slightly different. But you get the idea, right? You have signed metadata that comes back in that JWT. You give that to Vault, and then Vault verifies that, again, with the cloud provider. And then Vault is like, OK, I've verified the identity of this thing. I know I can give it basically a bootstrap token, like a first-time token to authenticate to Vault and grab whatever secrets the Vault policy allows, which is like the authorization layer, right? And so it's a really cool solution. This didn't always exist, actually. We were the launch customer for this feature with Google Cloud and HashiCorp, and I gave a talk at HashiConf in 2017 about this. And we wrote a pretty extensive blog post about it as well that includes a sequence diagram showing exactly how this negotiation works. So check that out if you're interested in the nitty-gritty details. And it's similar with Kubernetes, but it's not identical. I haven't looked at it in a while, to be honest, but I believe it's like the Kubernetes API server is essentially the broker. So that has to be trusted, and that has a long-lived token to auth to Vault. And then Kubernetes itself, the API engine, is the thing authenticating and validating the identities of all the pods. So it's sort of a similar thing, but there's a bit more hops involved in the trust bootstrapping. So for those of you who are not yet doing secrets management in production, which I think was roughly 50% of the room-ish, maybe 40, I was thinking about like how do you go from nothing to something, especially in an environment where you might have like hundreds or thousands of secrets and tons of different services and different teams that own different things. And I think at a high level, you basically want to make sure that you or whoever's working on this project with you and your team have a really solid understanding of all these concepts and the technical kind of like gotchas, right? Like the memdisk thing I mentioned, like the bootstrapping of trust for new VMs and pods. These are the difficult questions that that I guarantee you will get asked by smart engineers at your organizations. And if you have the answers for them, their respect and willingness to go along with this otherwise scary change will be much greater. So to drill a little bit more into the details on that, I kind of broke this into 3 sections. So I think the first bucket is like mastering really critical concepts, like those concepts I mentioned around identity, authentication, authorization, a solid understanding of TLS and PKI. This is not actually specific to secrets management, but in that table that I showed you about all the layers in the stack, right? notice how it said like encrypted on like all the columns on the right? The reason for that is because what we do at least, and by the way, that table really reflects our architecture, in case that wasn't clear. We actually use Vaults. Vault does other things aside from just key value secrets management. It also does things like act as your certificate authority for all of this infrastructure. And so that could be a whole separate talk. But basically, you can use Vault as your PKI and issue certs, mutual TLS, client certs, for all of your infrastructure. And that's exactly what we've done in every layer of that table that I showed where it says encrypted. That's all client certs from Vault. So all of the Kubernetes components that are talking to each other, even Consul, which actually sits underneath Vault, right? That's the distributed key value store. Every one of those layers is actually using mutual TLS. So if you don't have your TLS kind of, TLS and PKI, they go hand in hand, right? If you don't have your fundamentals there, I'd say that is really critical and will serve you really well with tons of different projects. So, and it also pretty much forces you to understand public key cryptography, which again also comes in really handy in a lot of different situations. So that's the second one. And then the third one is obviously like the top level concepts that are specific to Vault. Vault has like these concepts of like backends. It's just this abstraction for how they talk about like the different building blocks of Vault's functionality, the different features. And so I think having this high-level understanding that there are storage backends, so you don't have to use Consul. You can store things in like Postgres. You can store things in cloud-hosted database options from AWS and Google Cloud. There's a bunch of different options. They all have different trade-offs around like HA versus redundancy versus like ease of backups and speed of restore. The trade-offs are actually listed pretty well if you look through the database page on Vault's website. So dig through that. It's going to be highly dependent on your environment and your goals, like which storage backend you choose. Secrets engines. So the key value store is the default one that's just turned on out of the box. That's the really obvious one. You're like, I have a private key. I'm going to put the value of the private key, base64 forward. Boom. That's a secret in the key value secrets management backend. But there's a bunch of other ones. So another one that I didn't list here that we use that's super cool is called the transit backend. And it's basically crypto as a service that you can have your engineers utilize from the application layer. So I'll give our example because not as a pitch thing, but just because it's the only one I can think of. Like if you want to come in and set your corporate Wi-Fi password in our product, right? We can't hash that password because we have to send it down to the device in a config eventually, and it has to be able to join the Wi-Fi with the corporate Wi-Fi password. Well, and maybe there's a way to hash it, but the protocol doesn't allow you to do that from Apple. So we have to store it unencrypted, right? But that's pretty dangerous. So what you can do is make a call to Vault's API and say, I have this data, I want it encrypted. And it'll return it to you as an encrypted blob, and then you can write that to the database. So it's encrypted at rest. So that's really cool, obviously, because that means even if someone totally owns your production environment and steals everything in your databases, at least they won't get that super sensitive customer data. So I really love the transit backend as well. And of course, I already mentioned the PKI backend, so that's another example. So just familiarizing yourself with the different secrets backends and like what they can be used for. We'll also let you chime in sometimes in like those conversations with engineers more at the design phase where they're like, hey, I'm trying to do this thing. I'd like it to be secure, but it seems like it's going to be a nightmare to deal with managing all these keys if we want to do encryption. Like, where are we going to put them? How are we going to rotate them? How do we handle expiration, like on a schedule, like rotation? So Vault handles literally all of that for you. It's all built in. Rotation, you can make it so that if you're using the PKI backend, you have like short-lived client certs that expire after 1 day if you want to be super aggressive. So it's really flexible and allows you to kind of use it for a bunch of different use cases. And then last but not least is the auth methods. So I talked so far only about the machine authentication, right? You've got VMs coming up requesting secrets. You've got Kubernetes pods coming up asking for secrets, proving their identity, et cetera. But what about the humans? So there's also a bunch of different options for how you all and your engineers and security team members can actually authenticate into Vault as a human and add and remove new secrets. So some of the ones off the top of my head are SSH. Obviously, the obvious built-in one is token-based. It's kind of like API token-based auth. But a really cool one is the OIDC one, because that lets you plug into basically any OAuth provider. And so that's what we are moving to now, where basically you'll be able to log in if you're on the list of users that's allowed to log in, not just anyone, right? You'll be able to log in with your G Suite credentials, which is awesome because a lot of companies nowadays already have very strong protections on their G Suite, like mandatory 2FA, sometimes, depending on your company, mandatory security key only, which is unphishable. So if you already have those strong protections, just like you try to do single sign-on everywhere for all your SaaS apps to protect against password reuse attacks, you can kind of just take the same exact model and say, hey, we're going to put all our eggs in one basket, secure this thing really well, and use it everywhere. And so that's kind of the same concept as an SSH bastion model, right? Instead of letting people connect anywhere, create this choke point with great auditing, really strong config, and force everything through there. So that's a really cool option as well for the kind of human authentication story. All right, and last but not least, so we've covered two things. Just to recap here, the mastering critical concepts, getting comfortable with getting started is the second one, sorry. So the getting started guide is actually really cool. I think it's important, though, to master the concepts first, because I was reading through the getting started guide, and it still assumes a bit of baseline knowledge. And I think Mitchell actually acknowledged that in his Hacker News comment. He said we're working on making it more accessible for people just getting into this. But the Getting Started guide is really good if you already have those high-level concepts down. So it walks you through all of this stuff, all the way from starting the server in dev mode. Dev mode's a really cool thing. I'm really glad they built this in, because it kind of skips all of the bootstrapping stuff you have to do to make sure that Vault is operating. The Vault infrastructure itself is operating in a secure way, like all the TLS and all that stuff. And it just lets you dive in and start working with the actual command line tools, reading and writing secrets, and getting familiar with the concepts. So you can gain some confidence that this is a tool you actually want to use before you sink a whole bunch of time into securing it. So yeah, that's the list. I won't go through it in great detail, but pretty comprehensive. Even touches on the API at the end. And then once you have all the tech down, and the reason I put the tech down again, as I mentioned, is because I think you need to be ready to answer the hard questions by the time you start the human part of this, because that's going to help you and instill confidence. But once you've done that, I think the right way to tackle this is to explain the problem and the benefits to your immediate team, kind of like I did at the beginning with the Uber example, but maybe find a few more examples. Start maybe with talking with, if you're on the DevOps team, with your team. If you're not, maybe loop them in, your platform, cloud platform engineering team, whatever teams you have that do this work in this space, get them involved. And then once they understand the value, because they're going to be a lot closer to the problem than, product engineers that are working on customer-facing features. So once you have the kind of ops and security people all evangelized, then I think that's where you can start going and talking to the wider engineering org and say, hey, it's really important that we do this. We all believe this, but we need your help. And we're going to do this on a long time horizon. We're going to do it very gently. We're totally aware of potential for downtime when you're dealing with secrets. And so crowdsource, start early, talk to every team, talk to every service owner and be like, hey, we need you to think of all the secrets that are involved in your service and start documenting. And then over time, that will get, you'll probably get like 70% on the first pass, and then the last 30% will take months. But you will eventually get to hopefully everything. And then you can basically do a test in dev with all different secrets than you would use in prod, which hopefully everyone's doing that. But yeah, that should also help you gain more confidence again, right? If you actually do this in a non-prod environment and the cutover goes well, then that's awesome, right? And you can do that. You can do it one service at a time or one team at a time, even within dev. So you can really slice this up and make it a very gradual thing, so that by the time you actually push it out in prod, everyone has like pretty high confidence that nothing's going to break. So yeah, that's how I'd recommend approaching that. Another thing after the cataloging of all the actual secrets is, of course, figuring out who should actually get access to it, both which VMs and which pods, if you have containers, but also which teams and which humans. And this is also a very long process. I don't personally think this should be a blocker to people starting to do secrets management in production. I think it's raising the bar substantially, even if you start out by just getting all your secrets in here and not changing it. Let's say the status quo at your company is that everyone has access to every secret. Great. Then just don't change that status quo, because you've raised the bar so much, at least in the kind of foundational bucket of where all this stuff is stored, and you've set yourself up for success in the future by doing this. And that way, you can then take the same approach with locking down the permissions over time. But that's a lot easier once you have everything in one place, effectively managed and secured and encrypted at rest. So that's personally how I think this should be approached. Obviously, just my opinion. But yeah, that is pretty much it on everything. I wanted to leave a lot of time for questions on purpose with this talk, because there's so much depth in each of the areas, and I feel like, I hope at least, that people will have a lot of questions, and we can have like kind of an open discussion. So, thank you. Right there? Did you have a question? Oh, we have a mic. Awesome.
How does this come out? Okay. Are we going to? Can't see. That side. Okay. Like that.
By the way, I'd love feedback on my speed. If I was too slow or too fast, I would love feedback.
I guess a kind of question around, if you're putting all your secrets and your keys in hash vault, then that's kind of the keys to the kingdom. So what's your thoughts around, or how do you tackle like the break glass solution? So if things go wrong, you can recover all these kind of important secrets.
Yeah. So you're correct that it definitely concentrates all of your eggs in one basket. But I guess the idea is that it's just a very well protected basket. And it's not just well protected. And by the way, they publish their entire security architecture for this thing. It's public. It's been audited by, I think, NCC Group. I'm not sure, though. But it's super hardened. It's all written in Go, which also lends a lot of benefits, like mostly memory safe as a language, and great support for TLS built into the standard library. But to answer your question directly, yes, in terms of a break glass situation, a concept that I kind of skipped over, but which is made very apparent in like the Getting Started guide, is that Vault has this concept of unsealed or sealed. And when the servers first come online, they're all sealed. And Vault uses something called Shamir secret sharing, where you basically need a certain threshold of tokens in order to unseal and actually decrypt and operationalize the Vault servers and storage. And on top of that, there's a cryptographically backed audit log built into Vault as well. So every single action that's taken, through the API by a human, doesn't matter. I think even internal operations, Vault doing things itself, is all written to that audit log, which cannot be modified because it's, cryptographically signed. So yeah, you would, in a break glass situation, probably what you'd do is just seal it, and you'd have a full audit trail of all the attacker activity and know exactly which secrets were compromised and where, like exactly which VMs and which pods, because you have the logs as well of the bootstrapping, and you also have the logs on the the policies, which are like those authorization groups, like which things are allowed to access what secrets. So you could even threat model in your incident response what the worst case scenario is. Like if the attacker got onto this VM, they would have had a token that gave them access to this set of secrets based on this vault policy. So it makes it so much easier and clear and clean to do incident response even in that worst case scenario.
Hi, thanks for a great talk. What should I tell our Kubernetes admins who wants to use CL secrets and store encrypted secrets in GitHub?
Sorry, I just want to make sure I understood the question. So you're saying you're using GKE and you want to encrypt the secrets, but you want to keep them on GitHub?
No, I don't want to.
Okay.
I want to fend off the Kubernetes fanatic that want to store secrets using CL secrets. So the argument being, native Kubernetes resource custom type support and this and that. And I personally prefer, and I really don't want to put any secrets in repositories. But their argument being, strong encryption key, 4K RSI, and so on and so forth.
I see. So, yeah, I guess the argument is certain people have a preference for storing secrets in the same repo as the code, but encrypted within the repo. And there's definitely multiple options for doing that. I think what gets difficult with that approach is handling the rotation, having an audit trail of who actually accessed the secret, because were they just accessing the code or were they accessing the secret? Like, you really don't know. Yeah. So there's a little bit of convenience there, I agree. But yeah, I think there's a lot of things that are much more difficult, like the key management, rotation, auditing, some of the things I talked about. I think that if you kind of created I think the right way to approach that, if I were you, in that situation, is probably just create like a side-by-side comparison where you list out all of the kind of features almost of like a secrets management system, such as Vault, like the rotation, et cetera, on the left, and then you have like a few different projects, and you actually compare them with like green checkbox or X, and hopefully that would illustrate the vast difference there.
Yeah, hi. I probably have like 2 questions.
Yeah.
The first one would be, were you able to implement the password rotation?
Were we able to implement password
rotation? Yeah.
Password rotation?
Yeah. Like integrating HashiCorp with, for example, databases, so you can rotate the passwords automatically, and then just provide them to the systems.
Yeah. Are you asking if that's possible?
I know it's possible if you were able to do that in some part of or in some phase of your project.
Oh, I see what you're saying. I know we have looked at it. I can't remember if we have implemented it or not. To be totally honest
because
with you.
That's what we're looking into.
Yeah.
There's like, for example, your Wi-Fi password or the other incident.
Yeah.
For example, for incident response, you don't have to go manually into all the databases.
Totally.
You can just change them. Like if you, and we're looking into that also. That's why I was the other question would have been that in what phase did you come to the IT ops and said, okay, we want to rotate the passwords automatically. You don't have to look at them. Yeah. And the second question would be, do you run high availability?
Yes.
And do you have any idea of how many passwords do you provide per minute or per second? Or
oh, like what our throughput volume is? I don't know, actually. I would have to talk to our
because
head of cloud.
We're looking, have you ever heard about like CyberArk Conjure? That's something similar. And we were looking into that. And they always ask me, like, how many passwords do you want to provide? Because, like, we are not a company that would be able to do this, let's say, agile. So I have to have a project and set up everything up front in order to get the solution. So yeah, we were looking into HashiCorp. Sadly, we were not able to buy it and to have the support that our IT ops requires. Yeah. And we, are, as security, are not able to have enough people for anything, not even to run a HashiCorp. Yep. So we actually lost on HashiCorp. So that those are the questions. And for high availability, do you know what HashiCorp does? So you have like 2 locations, and how do they synchronize? Like just the pattern between the 2 databases that you have to have?
Yeah. So I actually had one more thought on your first question. Oh, password. Yeah. So I just want to make sure the whole audience is aware of what the thing is that you're asking about.
I jumped too deep.
HashiCorp Vault has a feature that lets you generate and rotate on any frequency that you desire the database credentials, the credentials that your application layer actually uses to authenticate to the database. So that's pretty cool. And it's also, like he mentioned, very nice in a breach scenario, because you could just rotate all your database creds everywhere with, like, the drop of a hat. So that was the first one. And then the second, sorry, I'm forgetting. High availability, yes. So not every storage backend supports high availability mode. That's why there's some trade-offs there. So that's actually why we chose to go with Console, which was sort of the first backend that was available with Vault, because we started using Vault like in 2016. Same with Kubernetes. So yeah, definitely choose the right backend for your environment. And I think that is also going to affect your throughput as well, of like how fast you can, how many requests you can serve. So we do Console across multiple regions, availability zones, so that we have a lot of redundancy. And then we also do like a snapshot of the entire Console, like distributed key value store on a schedule very frequently. I believe it's every 30 minutes. And then we back that up to Google Cloud Storage. So there's just like so many layers of redundancy, because you really cannot lose that data. It's very bad if you lose all of your secrets, or if it goes down. So HA and redundancy and backups, super important with this stuff. Yep.
Okay, sorry, there's one more question, couple of more questions. One here.
Hi, yeah. Would Console be your back end of choice if there's no other reason to go look for something else?
We haven't had a reason to change, but I also haven't looked really in depth at the alternatives and how things have evolved. I think someone told me that you can actually use 2 backends at once now, which I haven't verified this, but that could be pretty interesting to get kind of like the benefits of different characteristics of different storage options, to actually just use multiple. Maybe like one for writes. I'm not sure how that works, to be honest. Totally blanking out now. But someone very authoritative told me this information without naming names. So I think it is possible. I just haven't looked at it, and I'm not sure it's documented either. So. Any more?
Yeah, I was just wondering, what integration patterns did you play around with in terms of actually getting the passwords from the Vault? So as I understand it, there's kind of a native integration pattern where the application reaches out to the Vault and gets it. And the second one is, I think, a pattern that HashiCorp were playing around with maybe like a sidecar pod to inject the secrets into it. Just wondering which kind of pattern you guys went with.
Oh, yeah, that's a great question. I definitely should have mentioned that. So he's asking, like, how do you actually get the secrets into the pod within Kubernetes? Very good question. So the way that we do it is the only way I've really seen people do it, but it doesn't feel very good. And I think that there's better ways now, but I'm not sure exactly what they are, but I'll just answer the question directly. So we use an init container, which is a special container that runs before the actual container. That's going to like have a long-lived, well, maybe not long, but the longer running container. And so it just spins up, fires off a script, could be in whatever you want, I don't know, Python, Bash, connects to Vault, fetches the secrets it needs, and writes that to the mem disk. And then that mem disk is made available to the pod, the actual service pod that comes online and is the more long-running service. So yeah, that's the way I've seen it done. That's the way I've also seen it done by Kelsey Hightower, if you're familiar with his work. Awesome guy at Google now. But yeah, I think that's still kind of the way people are doing it for the most part. But now you're making me realize that I should revisit this. Good question.
Awesome. Thank you very much. Please give it up for Jesse.